We're going to look at some activities with infrared, and because they're waves, properties of waves involving a rainbow, the infrared from your TV remote, astronomical images, weather forecasting images, thermal images, and more. The last two involve buying a heat-sensitive sheet or some theatrical gel for the night vision goggles, whereas you can go to the site and actually look at them working as opposed to having to spend money. So the first one is about making waves. Infrared radiation is made up of waves of energy and a particular range of wavelengths in infrared, which is going to be different from all the other wavelengths on the electromagnetic spectrum. And so you can pause this one, but it involves people moving a rope, one person holding it still and the other person giving some vertical movement up and down and going on to part two, so pause for that one. And then looking at a rainbow, the rainbow is using a raindrop and sunlight to split the sunlight into the colours of the rainbow. And indeed, infrared is also there, but we cannot see it with our eyes. And some hints there to help you answer that question. And here you've got sunlight going through a prism, breaking the sunlight into the colours of the rainbow, and a raindrop will actually do the same if the sunlight and the raindrop are in the right orientation to you as the observer. And looking at those waves, each of the colours of the rainbow have different wavelengths, red being the longest and infrared adjacent to longer still, and microwaves and radio waves even longer. And on the short end, the blue, the violet, going to ultraviolet, X-rays, gamma rays, and gamma rays with wavelengths as short as an atomic nucleus. And then go on to an experiment with a TV remote and a smartphone. Obviously, you have to have access to those to do this, and there's a link there to the instructions, which is quite an interesting and straightforward activity to do. And then here, looking at the image and answering the questions. So you've got a visible light image and an infrared image of the same nebula, and some questions. What can you see? What makes an infrared image more useful to an astronomer, perhaps, than a visible light, or indeed vice versa? And to compare infrared images for weather forecasting. And this is from the GOES satellite, Geostationary Operational Environmental Satellite. And for the IR image here, and why is that one perhaps more useful, looking at clouds that are there for weather forecasting? And the bottom right there, check out your region's IR image at the NOAA link that's given. And night vision versus thermal imaging, go to the link there to see that. And then problem 9, which is given below here, audit on a home or buildings there, and where is the most heat loss occurring? Is the building on the right compared to the building on the left? And how would you insulate to reduce heat loss? And infrared and space telescopes, the atmosphere actually blocks infrared. So if you want to do infrared detection from astronomical bodies, you either have to get on a really high mountain in an airplane or indeed in a satellite or a space telescope to eliminate the problem that the Earth's atmosphere would cause. And here you've got part of the electromagnetic spectrum. Now it looks like all of it, but just part of it covered by those 3 space telescopes. And use that diagram to determine which of the 3 satellites listed, 1, 2, and 3, are best for infrared imaging, and give a reason for it. And then there's a cost here for the heat-sensitive sheet, and you can look at the experiment with the effects at that link. And again, there's an expense of buying theatrical gels here, but you can go there and look at the activity without having any expense at all. And finally, check out some more at this Smithsonian Learning Lab and discover about astronomy, wildlife, uses of IR, and some more activities and artifacts that the Smithsonian has.